Now I'm going to give you an example. So in the previous video, we've seen that when you have two vectors, if you compute the cross product, so your vector here, and then always insert these unit vectors, compute this whole thing here, compute the cross product. This whole thing here will give you this vector here, the purple vector, and the purple vector will always be perpendicular to the plane of the parallelogram. I will explain more on this because if at the moment you've got u cross v, so you're going in this direction here, and then it will go up. But in the future, I will explain why if you switch the two around, it won't be the same when it comes to the cross product. It will be. Hang on, let me clear this up. In the future, I will explain why when you do it this way, then it will go down. It won't go up. It will go down in this direction. The vector, this vector here, will then go in this direction. I will elaborate more on this next time round. But the point is that with two vectors, you can identify this vector here, and you can also work out the area of the parallelogram. So let's put it to the test. So hang on. So let's say you've got two vectors here, 1, 2. So the first one will be 2 across in the x direction, 1, 2, and then 1 across in the y direction, and then 1 up. So roughly speaking, it's this vector here in 3D space. So you've got to imagine it as this short vector here, and then this one here, this vector here, it will be -4 in the x direction. So it's 1, 2, 3, 4, roughly somewhere around here. And then 3 across in the y direction, so it's 1, 2, 3, and then 1 across in the z direction. So you've got another vector here. So your vector here is somewhere around here. So you've got one vector here, and then you've got another vector here. So these two vectors are not parallel, so they will form a plane, like a sheet of paper. Imagine it as a sheet of paper. It would be a plane. Now we want to identify a new vector where it's perpendicular to the. So we are going to try and compute this vector here where it will be 90 degrees to one vector and also 90 degrees to the other vector in 3D space. Okay, so we look something like this. So we are going to try and figure out this vector here, and then this will form a parallelogram in 3D space. It's hard to visualize it, but it will form. So we're going to work out this area here as well. Okay, so let's start again. Hang on, bear with me. So we've got hang on, bear with me. So at the moment we've got two vectors. This one here and this one here. So we are now going to somehow work out this vector here that's perpendicular. This vector here that's perpendicular to the other two vectors. So we just need to compute the cross product. And remember, at this moment, you don't understand why it works. Just accept that when you do the cross product here, it will give you that perpendicular normal line, normal vector. So let's just compute the cross product. So you've got two vectors here. Let's insert the unit vectors I, j, k, and then insert the 2, insert the 1, insert the 1, and then insert the -4, insert the 3, insert the 1. So the cross product will be similar to the determinant. So it would be looking at this, discard the horizontal, discard the vertical, and just look at this. And then looking at j, discard the horizontal, discard the vertical, and just look at this. That's this bit here. Remember, it's got to be a minus. So it's plus, minus, plus. When you get to linear algebra, minus, plus, and so on. But then now you would look at the k, discard the horizontal, discard the vertical, just look at this. So now determinant, so it will be this times this, and then take away this times this. So that would then give you this. And then looking at this, it will be this times this, and then take away this times this. So take away well, this times this will be negative 4. So that's like this plus this, that will be 6. So this whole block here will be a positive 6. But then you've got a minus, minus, this is a 6, this is a 6, and so on. And then it will be this times this, which will be 6. Take away this times this, which will be negative, negative 4, so that will be blah, blah, blah. That will then give you 10. So the vector, so of our vector here, the one that was perpendicular to the other two vectors will be given by this. So it would be given by this. Okay, and the area of the parallelogram. Well, the area of the parallelogram will be us finding the magnitude of the cross product. Remember, we've just computed this cross product. So the cross product itself would be this thing here, which is that perpendicular vector. But then if you want to know the area of the parallelogram, remember there's a theorem that says the area of the parallelogram is equal to the magnitude of this vector here. So at the moment you don't know why it works. Just accept that the area of the parallelogram is given by the magnitude of this vector, which will be us using Pythagoras. Square this, square this, square this, square root the whole thing. The magnitude will be given by that, but the magnitude is equal. The magnitude is equal to the area of the parallelogram. So this is your area here. This is your area here. Okay.